Hey, 7th period, it's Mrs. Jennings. I'm going to do 2 videos for you guys that are going to help you with the last material that you need to learn this year for 8th grade, algebra, which are simplifying rational expressions and multiplying and dividing rational expressions. So this is Chapter 7, Section 1 first. So first thing you need to know is when we say rational expressions, it's just a fancy name for fractions, but of course those fractions are going to have algebra in them. So the first thing we're going to do is we're going to go back to math and we're going to review just simplifying fractions. Such as if I gave you the fraction 20 over 24 and I asked you to simplify that, or another name for that would be reduce it, you guys know by now that you're going to look for the most common, the greatest common factor of the two numbers and divide it out. But let's go one step back further, because technically what we're doing when we reduce fractions, we just don't do this process anymore because you can do this in your head, is we're actually doing the prime factorization of both numbers. So 20 is 2 times 2 times 5. And 24 is 2 times 2 times 2 times 3. And to simplify, what we're doing is we are looking for what is in the numerator and the denominator that is alike that we can divide out. So here we go. A 2 divides a 2 out, a 2 divides a 2 out, and that's it. So everything else that they have in common, they don't have anything else in common, so we can say the answer is 5, 6. 2 times 3 is 6. So when you do 20 over 24 and you reduce it, technically that's what you're actually doing. Okay, so when we say that we're going to work with rational expressions, like I said, that's just a fancy name for fractions with algebra in them. Here's an example of 3 different rational expressions. Each of them are fractions, but if you notice on top and bottoms, in some of them we have monomials, in other ones we have trinomials, we have a binomial. I'm going to show you how you actually simplify rational expressions, and it's very similar to how you simplify just normal mathematical fractions. So here's the first one we're going to look at. 6x squared over 20x cubed y. We want to simplify this rational expression. So the first thing we're going to do is we're going to factor both the top and the bottom. So 6x squared, that would be 2 times 3 times x times x. 20x cubed y would be 2 times 2 times 5 times x times x times x times y. All right, so to simplify the fraction, we're going to mark out anything that's alike on the top and the bottom. So we've got a 2, we have an x, we have another x. Nothing else is alike. So my final answer is 3 over 2 times 5 is 10, and I have an x and a y on the bottom. So 3 over 10xy. That is what 6x squared over 20x cubed y simplifies to. We've reduced that rational expression. Okay, so here's our next example. Negative 4p squared plus 3p over p cubed plus 2p squared plus p. Now, the first thing you need to know is we are not going to separate these into monomials. We have a binomial over a trinomial. So we have to think about how are we going to factor a binomial and a trinomial. So this goes back to the factoring chapter. And you got to remember, how do you factor all polynomials? So on the top, the only thing we can do with that binomial first is ask ourselves, is there a common factor? And there is. There's a p. So I'm going to factor a p out, and we get negative 4p plus 3. And on the bottom, what do they have in common? They have a p in common, so we're going to factor out a p. And we get p squared plus 2p plus 1. But the important thing here is we've got to make sure, have we factored everything completely? So on the top, I know that there is nothing else I can do to what we have on the top. I can't factor it any farther. But on the bottom, I know that the trinomial p squared plus 2p plus 1, I know that factors into p plus 1 times p plus 1. And the reason why you have to do that is because we have to factor everything completely, because otherwise we may not see things that we can actually cancel out. So now I've got everything factored completely. I need to look on the top and the bottom and see if there's anything alike that I can cancel out. So if you notice, I have a p on the top and a p on the bottom. Okay, now I know there are other p's, but these p's are on the outside by themselves, so we can actually cancel those out. Now, notice on the top I have the binomial negative 4p plus 3, and on the bottom I have p plus 1 and p plus 1. Those are not alike. We cannot cancel them out. Now at this point I always have students go, yeah, but what can you cancel out the p on top and the p on the bottom? And the answer is no, because the p on the top and the negative 4p plus 3 and the p on the bottom and the p plus 1, they're part of binomials, and we cannot change the look of a binomial. So the only thing that this problem had in common that we can factor out was the common p, greatest common factor on the outside. So my final answer to this problem is negative 4p plus 3, and you even leave it in parentheses in factored form, over p plus 1 times p plus 1. And that's my final answer. That's reduced. Okay, so now we've got x squared plus 5x plus 6 over x squared plus 4x plus 4. We have two trinomials, so we need to try to factor them. Okay, now on the top and the bottom, neither one has anything that we can factor out for a greatest common factor, so we need to try to factor the trinomials. X squared plus 5x plus 6. Okay, I know that factors into x plus 2 times x plus 3. X squared plus 4x plus 4, I know that factors into x plus 2 times x plus 2. Alright, I can't factor anything else, so now I'm ready to ask myself, can I cancel out anything? Well, if you notice on the top and the bottom, they both have a binomial of x plus 2 in common, so I can cancel that out. What's left is x plus 3 over x plus 2, and because those binomials are not the same, I cannot mark them out. I can't mark the x's out because those are part of a binomial, so my final answer is x plus 3 over x plus 2. Okay, here's a new one. Why don't you try factoring this one? So pause the video and try simplifying this rational expression. Alright, so what you should have done was, on the top you have the difference of two perfect squares, so you should have factored it into x plus 3 times x minus 3. And on the bottom, you should have made that x plus 3, x minus 2. Alright, once you did that, you will notice you have the binomial x plus 3 in common on the top and bottom. And then I can't do anything else, so my final answer is x minus 3 over x minus 2. Done. Okay, try one more. So pause the video and simplify this rational expression. Okay, so on the top, I can see first of all that there is a common factor of a 2. So I'm going to pull it out, and I get x squared minus 4 on the inside. On the bottom, they have a common factor of 4. I can factor it out, and I get 4 times x minus 2. But now what I have to notice is on the top, I've got a difference of two perfect squares, so that one factors again. And I get 2 times the quantity x plus 2, x minus 2, over 4 times the quantity x minus 2. And had I not factored that binomial on top, I would have never known that these now have two things that we can cancel out rather than one. So first of all, I know my 2 goes into my 4 2 times. And I know x minus 2 cancels out x minus 2. My final answer is x plus 2 over 2. No, you cannot cancel those 2's out because the one 2 is a monomial and the other 2 isn't part of a binomial, and you cannot break up a binomial. So my final answer is x plus 2 over 2. Okay, now this ends the notes for 7-1, simplifying rational expressions. In your final exam review packets, there are now a few more problems that you can do on the ones that I told you you hadn't learned the material yet. Now what you also need to do is you need to go on and you need to watch lesson 2, which is on 7-2. That's going to be a whole new video.